So lab 4 is going to be about strain gauges. So what is a strain gauge? Strain gauges measure the strain in a specimen or component. Strain gauges are usually bonded with a special adhesive to a specific location where the strain is to be measured. The strain gauges used in this lab are basically variable resistors that change resistance based on the amount of tensile or compressive strains applied. Loading conditions. These strain gauges are primarily sensitive to longitudinal tension and compressive strains. And that's the strain pictured right there. Strain gauge right there. The voltage output of the gauge. Wheatstone bridge circuits, shown here, are used to convert the resistance change of the strain gauge to a change in the output voltage. Wheatstone bridge types. The types of Wheatstone bridges are the quarter, the half, and the full bridge. And a quarter bridge is shown on the right, which is with just the one strain gauge. The half bridge is shown on the right, is to maximize the voltage output, where one gauge is exposed to tension while the second is exposed to compression. So you have these two. And then the full bridge circuit is shown on the right, where all four gauges are stressed and arranged to maximize circuit output. So you have these two right there. That'll be possibly on the top, and you have the other two strain gauges that'll be located on the bottom. When you load the different weights at this distance from the strain gauge, you'll have 12 different masses that you will use. Here we have the experimental setup for lab 4. We have the beam right here. This is the beam we'll be using. This is the loading point where you'll be putting all those different masses on the beam itself. The beam will be attached to the table using a C-clamp to keep it from moving. Right here, you have two strain gauges on top and two strain gauges on bottom that are covered by a special adhesive that then run into a Wheatstone bridge that we're using as a full bridge circuit that then runs to your NI DAC device that will then run into your computer, and where you have the different masses. This is the experimental setup. Since we already have a mass loaded on the beam itself, we can go ahead and hit run. And these are the different values. So you have the mass, the B, the C, and the D will be given to you. You'll have to come up with a number of samples and a sampling rate that is sufficient. The E will be your strain. E, the capital E, will be your Young's modulus. You will also be given the mean and standard deviation of both those values. And you'll have the sigma value, which is your stress.